Hello and welcome to the webinar. Today's topic, open source database performance monitoring. On this event, you'll learn about one of the most innovative database performance monitoring solutions in the industry today. This is presented to you in partnership with SolarWinds and produced by Actual Tech Media. Thank you so much for joining us. Before we get started, just a few things that you should know about the format of the event today. My name is David Davis of Actual Tech Media, and I'll be serving as the moderator. We want this to be an educational event here at Actual Tech Media. I mean, the point of all of our events is to help IT professionals such as yourselves overcome your technology challenges. And to that end, we'll be doing a dedicated Q&A session at the end of the presentation. So we encourage your questions. Get those questions in early. We also have a best question prize. I'll talk about that here in just a moment. I also want to call your attention to the handouts tab. It's there that you'll find three different PDF resources. There is the DevOps for the database ebook. There's a case study on how Etsy adopted the solution you'll learn about today. And then 5 things to know for MongoDB performance tuning. So make sure that you check out those resources. And then finally, at the end of the webinar, I'll be announcing the winner of our Amazon $300 gift card door prize. If you're watching this on demand, of course, the drawing has already occurred, and the prize terms can be found there in the handouts tab. As I mentioned, we've got our best question prize for an Amazon $50 gift card. Every time you ask a question, you'll be entered here into the drawing, and we'll select the best questions after the event and contact the prize winner then. Of course, you still must meet the Actual Tech Media prize policy. So we've got a great presentation. We've got a live demo. This is going to be a lot of fun. I'm excited now to introduce you to today's 2 expert presenters. Welcome, Mr. Nick Kaminsky, Sales Engineer at SolarWinds, and Mr. Jared Hensel, Senior Product Marketing Manager at SolarWinds. Nick and Jared, it's great to have you. I'm first going to hand it off to you, Jared. Take it away.
All right. Thank you, David. Excited to be here. So what we're going to talk about is our product called Database Performance Monitor and how it can help you monitor, tune, figure out how your open source database environment is performing, and basically take it to the next level. Before we get to the demo portion of it, I'll keep this short. Basically, I want to do a quick overview of basically SolarWinds. I know we've been in the news a lot lately, and most of you have heard of us from prior, basically being the network company, basically being heavily associated with Cisco and their networking products. But we've made tremendous strides on being all in the database market, multiple on the systems market. So again, this is just a brief overview a little bit about SolarWinds. We've been around now for over 20 plus years. We are the number 1 network management monitoring company, number 3 in ITOM, and basically that the database monitoring falls into what Gartner classifies as an ITOM, IT operations management category. So again, that's where we're putting a lot of our emphasis is on those type of products, ensuring that practitioners, administrators, DBAs, developers, they have the tools that they need so that they can actually do their work. They're not having to worry about a monitoring solution. They're not having to really worry about what their code is doing or what the database is doing, because we're going to take care of that for them. I reference basically Gartner's ITOM. Essentially, this is our little riff on there where we've kind of got all products and all these pillars. Obviously, we're going to focus right there on the one dead smack in the middle, the database performance management. So again, typically this has been the Microsoft and the Oracle, but really with MySQL, Mongo, Postgres, all these databases, I mean, they are growing like crazy. Really, in conjunction with the advent of the cloud, these databases are really able to shine. So again, it's your same practices you've had 10, 15 years ago with SQL don't necessarily apply if it's, Postgres or MySQL, things like that. So again, the product Nick is going to show is basically Database Performance Monitor. And so a little bit about it real quick. It is a SaaS platform, so it allows you to get up quickly. We don't want anybody, systems administrators, DBAs, developers, they should not have to worry about their monitoring solution. That should be taken care of. It should alert them when things are funky. It should show tracks, trends and changes over time, whatever it is, connections, you should not have to worry about it. So again, being a SaaS platform, you can be up and running super quick. You just create a trial, basically, and put an agent out there, and then all of a sudden, you're talking in a matter of 15, 20, 30 minutes, you are up and running gathering data. The product can do a number of different things, though, and one of the things is, it's going to allow you to see your overall database and system health. So again, we're going to also pull some metrics for AWS, things like that, so you can sort of see some of the stuff under the covers. Not necessarily all your providers, if they're cloud-based, give you under the hood information. But when we can grab it, or if it's an on-premises install, basically, something behind a firewall, or even if it's a virtual machine, we're going to grab some of that performance data so you can see, hey, there's a correlation between CPU and queries or IOPS and things like that. So again, obviously it's some of the basic stuff, but it does allow you to dig further in there. Before and after comparisons. This is a great thing because, obviously if you're doing code changes, this is excellent. Hey, I pushed code at midnight. I want to see what it looked like. But again, I can't tell you, just in IT terms in general, a ticket comes in and usually you're asking whoever put the ticket in, what changed? What'd you do differently? When was it working last? So again, if you've got some of that information, hey, it started at 10 o'clock. I didn't change anything. Oh, we did this. This is a great way to use this feature, is just kind of see, okay, hey, let's put a plot in there and see exactly what happened. And then you got your query analysis. Again, you could see things over time, latency. You can see if it's death by 1,000 cuts because it's been executed a million times, or hey, no, it's truly a slow running query. It executes a normal amount of times. It just takes a long time to happen. Obviously, you want alerting if something's funky. Hey, I don't want to be in the tool all the time. As great as any of these solutions are, I don't want to look at the tool all day long. I've got other things to do, but I want to be notified when something does go awry. But when I am in the tool, I do want to be able to customize it the way I want it to. I want to see if I'm only in charge of a certain database type, if I'm only in charge of a certain location, or whatever it is, I've got the ability to make some customizations. And then obviously, if it's a SaaS option, we do make sure your data is protected. It is GDPR and SOC 2 compliant. So again, you're just not having the stuff sit out there. What sets DPM apart? Because a lot of people, that when they start thinking open source databases, they're coming from an APM point of view. Hey, I've got, there's a number of great APM solutions out there, and they do lead you to a database problem. They do kind of lead you down there. But again, it's not what is actually going on in the database. They're just sitting there and saying, hey, somebody went in and it took 10 minutes to come out. I can't tell you what was happening or what other activities were going on in that database. I just know I waited here for a while. So, what sets it apart from APM solutions, other database monitoring solutions is, we are showing you everything that database does, the internals, all that kind of stuff. We're going to be able to pull all your databases or thousands of databases into single screen, single views. You can create multiple views, but basically you're not having to log into different tools. You're not having to go, okay, hey, this thing can only handle 10 databases and then it maxes out. We are getting data down to the second. So again, you're in this type of high velocity world, SaaS world, if you're taking averages of averages, you're going to miss a bunch of stuff. So you're going to have to really see, hey, what was exactly happening at 12:05? Zoom into that detail to see what's going on. And then really, with multiple organizations running multiple databases, everybody's asked to wear all these different database hats, and it is challenging. So, we've got some database recommendations. They're intelligent. They're based for the particular database itself. So again, you may be familiar with the product and you may be familiar with MySQL, and somebody says, hey, I've now got a Postgres database or something like that. Okay, cool. I've already got most of the stuff in place, and this can help you now with those recommendations, take it to the next level. I've thrown out some database names. Obviously, it can handle traditional, open source, and cloud native, physical, virtual, doesn't matter where it is. We've got everything from Azure SQL to Microsoft SQL, and then obviously the open source databases we're going to focus on today: Postgres, MySQL, Mongo. We also have Amazon Aurora and Redis. So again, if you're transitioning between databases, if you're a blended shop or blended IT department, we've got you covered. So again, we don't want to say, hey, one database, one location, that's all we do. We want to be your one-stop shop for all your databases, but we're going to talk in particular about the open source ones today. And who's typically, who are we talking to on sales conversations at trade shows? God, that was so 2019 being at a trade show, it's been forever. But on calls and who we see out in the field, things like that, we're talking to obviously your systems administrator, your developer, obviously DBAs, engineering managers. These are all people that are actively using DPM every single day. So it's not just, hey, this is specifically built for a developer. Hey, this is specifically built for a systems administrator, and it's just going to show, is it up, is it down, things along those lines. We definitely want you to use the tool regardless of what your persona is or kind of what your role and responsibilities are, because there's always something you're going to get out of it. Some individuals may drill 5 layers deep and look at explain plans because that's what they're into. They're more of a DBA. They understand it. And somebody may be more on the system side and just so, okay, hey, I can look at some of the CPU, RAM, and IOPS and pull some of those stuff in there and make some adjustments according to those slides. So, what is the progression? And this is where I think Nick's demo is really going to shine is, obviously, I'm going to actually talk about these out of orders. Really a lot of it is just getting your overall database health. Like, what is it doing? What I don't know what I'm looking at. I just need this thing to monitor everything. Okay, so now I have some baselines. I understand what's going on. I kind of know where all the players are at. And then you get into the troubleshooting performance. Hey, okay, nobody's actively making any changes, but I see opportunity for improvement. This is where I can get in there and I can start tuning queries. I can change I can reduce resources, anything like that. Where hey, now I'm trying to drive it to the next level. And then obviously, you go to the first one is basically deploying code. Is hey, I'm making changes, or hey, I'm doing updates. Okay, now I need to monitor performance again before and after using those timestamps. And then it's a rinse and repeat. Then you go back to the beginning again. Okay, hey, I've done a code deployment. Everything looks good. Okay, now let's go back to the beginning. Let's start not re-baselining, but see the overall performance impact. Hey, we pushed it at noon. Everything seemed to be fine. It's a day later. Where are we at? And start rinsing and repeating. You're kind of in this cycle over and over and over again because everybody's database, even if you're not changing code or applying updates or patching or doing anything like that, just the pure database usage of people signed into your application processing transactions. If you're an e-commerce store, how many widgets are being sold or manufactured, whatever it is. So even without the code deployment, just the actual database usage is going to change every day just based on the way people are using the application, the front end type of stuff. So with that said, I'm going to kick it over to Nick to actually kind of show how this does it and really focus in on the open source databases and how to really drive it to the next level.
Awesome. Thanks,
Nick.
Jared.
All right. Thank you.
Yep. I am pulling up my screen share now and hopping over to the DPM application. Can you see everything okay?
Yes, sir.
Perfect. So, yeah, to start us off, I guess I just want to kind of take a step back and kind of build on DPM because it is a really powerful solution. As you can see here, there are a variety of different pages that essentially aggregates and surfaces insight into different data sets based on all the metric data we're capturing, where you might want to look at the data through one lens versus, looking at it more from a troubleshooting lens or a summary view or here in the profiler. So there are a lot of ways that we can use the metric data and use the solution here to actually gain that insight. But I think it's important to quickly scope how typically our users will approach looking at maybe getting really specific detail into one server, or if maybe they're operating at a smaller scale, or potentially they're looking at hundreds to thousands of servers and they have a very wide fleet that they need to bring all into one place. So across the different database types we support, I can quickly look at the host and time filter here And this is really the lens that I try and build everything else upon, because these are essentially going to govern the data that we're looking at by specifying the servers of interest that we're looking at. So whether you're in a microservices environment and you want to focus on just the database instances focusing on one application, and I can use our advanced syntax to actually surface that exact example with a guestbook application here in our demo environment. These two MySQL servers, where if I apply this filter, I then will only see metric data specific to those two hosts. So I can use the advanced tagging and filtering to also maybe specify a database type. So let's say I just want to focus on the MySQL instances across my fleet of different database types. I can just focus on those 9 servers by applying that as well. So I can really drill into specific servers of interest, or get an aggregate picture across a wide ranging data center across multiple database types, to where I can get that insight into what's driving the workload and where change might be impacting the system the most. So I will leave these unfiltered so that we're looking at kind of the functionality across all the different open source database types over the last hour. And along the way, we'll probably toggle the time filter here, but just know that you have a lot of flexibility in also defining the time period we look at, so that you can really treat this like an analytical tool and get historical context into how those resources are changing over time, with very specific definition of the time frame that we're looking at. So with that, I want to drill into the specific features and pages. The profiler is generally where a lot of the journey starts in DPM, because this is where we're ranking, sorting, and filtering top activity. And you can see the time series of a specific query level metric across different queries in this matrix view. So I can easily drill into the different data sets here that I can rank by. And there's quite a few, so I don't want to focus on any one in particular, but across the list here, we can see that we can look at maybe a distribution across different logically defined databases, as well as table and collection based data. And then for folks who are used to working with the process list and really looking at long running statements and at the point of execution, as they're actively uh, looking at long running statements in the workload, you can actually get a pretty good idea of what those long running statements look like across different database types. So with that, I can really slice and dice across the workload and specify exactly what data set we're ranking and exactly what uh, dimension we're ranking that data set by. So if I, for instance, wanted to look at the distribution of all of my queries by the most voluminous to see really how that workload is distributed, I can do that. Or I can leave it on total time and maybe examine some of these other dimensions as additional columns that I can add, and then use these to sort. So I can see across my most time consuming queries, I see, for instance, this top insert statement across all servers that I'm looking at in this environment. This query is responsible for about 17% of total execution time running queries across all of the monitored servers. So I can quickly see for the heavy hitters here what the general profile looks like in terms of that total time, which is just a product of latency and count. So I can see if there are spikes or maybe more uniform profiles that shows kind of a steady execution pattern across these different statements. And as you can see here, this is examining a combination of MySQL, Postgres, and MongoDB statements. So we're really across the board looking at how all of our databases are performing kind of through the same lens of the query level analytics, and then being able to also use these sort columns to say, to maybe look at another dimension while keeping the ranking distribution the same. So I can see among my most time consuming statements, is it really those slow statements that might have a high average latency? We see in this case that might not always be the case. And there are some cases where that, death by 1,000 cuts, kind of a high count mixed with a marginally decently high latency, on average can really cause bigger performance degradations in the workload than we might have anticipated. So we can really get an idea of how our resources are performing, especially relative to each other, and then use this view to get to the bottom of what's driving potential slowdowns or problems in the workload. When we notice a specific query that is especially problematic because we're capturing 100% of server execution data, but in a case like this, we might want to look at, one specific query that's in this top list. And so I can click into that detail page, and for every single query that we're monitoring, so essentially everything that's running against the server is going to be captured and sampled. And so we can see the normalized digest of that query. So without any placeholders filled out with unique identifiers or variables, I can see the, for instance, total time count or average latency graph over the time series we have set here, as well as some samples where I can click into maybe one of these higher latency examples that shows kind of a spikier profile at this point in time, and is going to give me this deep level of sample information on exactly how this query execution was run, by what user, the origin of the request, when it started, and how long it took. So with this, I can also get additional information into error-related data or additional inefficiencies that the agent itself that's in place is able to pick up on and essentially recommend better ways to write the query or perform specific data operations that could bring down the latency of this statement, for instance, by avoiding a sequential scan and maybe limiting the amount of data that's read by this statement. So we're able to surface a lot of information very quickly just by examining the detail page for this individual query. And when we find insights like this, where there are cases where it's clear inefficiencies that we can quickly point the team to, a great additional feature is this share link feature, where I can copy and actually freeze a time range with a short link of exactly what I'm looking at and send that to another teammate on, who might be working with me and responsible for actually making the modification and optimizing this query. They might just need a point in the right direction. So we try and make it easy to use this for collaboration and bring all of this data in one place so that the team doesn't have to look around and analyze performance data from multiple sources. Additionally, too, this page is very powerful because we also aggregate all of the query level metrics that we use to rank, sort, and filter by in the profiler. So I can actually mouse over and see at a given point in time what a certain value was at that given second. And I can also get an idea of across the board what the profile of each individual statement looks like. And so I have this really deep 1 second granularity visibility across the board at exactly what this query's execution profile looks like, when it changes, what additional metrics might be worth looking into that might be a driver of inefficiency. So for instance, missing indexes and count being closely related, you might find cases where adding an index will cause this query to execute much more efficiently. So there are ways that we can start to get to the bottom of what's driving the query inefficiencies and use this data to kind of fill in the gaps and start to make improvements in the system. Additionally, too, the host breakdown and tag feature is worth mentioning. And with this query specifically, there's a great example where we can see across all of the 65 database instances that we're looking at that are monitored in this environment, there's 6 that are responsible for running this query over the last hour, and we can see the distribution of those individual hosts across the board by different dimensions. So if let's say I have a sharded environment and I have multiple servers running the same query, and I see a slowdown across one, for instance, we see a lot of total time attributed to this staging one server, But if I toggle over and look at the distribution by count, I see that this staging one, the same server, is responsible for less than 2% of the total execution count. But because of how slow it is in the few times it does execute that query, it seems to be a huge driver of that total time. So if I was trying to create a picture of what we need to change, is that those immediate steps to really bring down latency, I would point towards this server specifically. And what I could do is actually apply that to the host filter very quickly by clicking in. And now I will only get the samples and execution statistics relevant to this host itself. So I can see that across the board, changing the host filters now completely changes exactly what data I'm looking at and puts it through the context of exactly the server of interest. So I can use this to get to the bottom of those problem servers and then really understand exactly how these requests are being handled across the board. So, and then additionally too, for organizations that leverage query tags, we can track these. And so let's say you have multiple applications or logical databases that are responsible for a very complex workload. And I'll just use a very basic example here and choose the database equals Postgres tag. This is something that the agent is automatically tracking and categorizing over time. And I can then use these filters. What I'll do is go ahead and clear the filter here and jump back to the profiler. And I can use those filters to then do an additional level of filtering. So if I've, for instance, use the advanced syntax to say just my guestbook application, and then I know that maybe there's a specific database across those instances where there's a query tag that I can use to filter down. Let's say the Postgres database as just a hypothetical example. I can apply that and use that to just look at the workload that is associated with that query tag. So I can only look at queries in this rank, sort, and filter view through the context of which statements are also associated with this database by my own custom tagging scheme. So using these features kind of in conjunction and being able to get detail at the query level is really what drives the troubleshooting performance problems very quickly, because we try and use this organization of data and the ability to make quick decisions based on that data in a reactive and proactive sense. So the other key aspect of the profiler is the ability to bring in event related data. So the agent is not only capturing the full picture of the database infrastructure and query workload on a per query basis, but we're also analyzing that metric data in the background to point out when we might be, for instance, approaching max database connections, or when there's a server restart or other performance related issue event markers where we can kind of get an idea that maybe something in the workload changed, and we want to line up when one of these events happened alongside the query data to see did this event possibly cause a problem, or was this event caused by a query performing poorly, for instance. So if I actually choose the app deployment event here as just an example, this is a case where maybe I make an intentional change and I want to do that before and after comparison that we were talking about earlier. So I can quickly drag and drop and just change the time filter by looking at that time period following that event, and then use the last hour of time with the compare time range feature to not only see in gray versus teal how things have changed in just the last hour, but also following that event versus the workload before the event. Was there a significant increase in that total time or other metrics, or maybe decreases as a result of improving the system? So we can quickly get to the bottom of before and after those problematic events. Like, let's say you're an on-call DBA who gets paged and there's an application issue and they think it might be the database. You can quickly pinpoint exactly when that problem event occurred and then look at this delta to see, was this something related to the database, or is this something that maybe the application team needs to take a closer look at? So it's very easy to validate and verify using this top activity approach with the compare time range feature to get to the bottom of what does baseline behavior look like, and when we do see a problem, where is the impact of that problem most focused or concentrated across the very tangible workload that we can look at. And so with these two features, you can do a lot with the profiler, but it also doesn't answer all the questions that we might want to answer with a solution like this. So I'm actually going to transition very quickly to the Explorer page to kind of build on the profiler feature set that we were just looking at. What I am going to do is clear the filters out just a little bit, so it's a little less noisy of a visualization here. But kind of starting from the top, the Explorer is a great combination tool with the profiler for being able to correlate query performance and system behavior and really understand among the workload when we see a query misbehaving or a specific problem related to a very granular dimension in the workload, like processes or individual user activity. I can also pair that and essentially look in a vertical fashion over the same time series and see those infrastructure and system level data sets and essentially make correlations where I can answer questions like, when this query became a long running statement and spiked in total time, did we also see an impact to CPU, or did this explain this memory issue that we experienced that caused this other issue? So you can start to really get visibility into those specific types of problems by being able to pull the query and system state data into the same view here. So I'm going to kind of walk up from the bottom to the top and essentially answer the question that's shown here through the lens of just our MySQL servers. But essentially, I can look at my top 30 queries here by total time. We see that the y-axis here is essentially a measure of time. So that's essentially, we can treat this as an idea of what does the average response time look like for our top statements. And so we see that there are these large spikes with not much else. If I start to peel away the layers here and take away this insert statement that is causing the spike, we start to see these other colors where the y-axis here is much smaller, because we can see that there are all these other statements with much more reasonable average response times. And then when I add these insert statements back, we see this massive spike where it's not running consistently, but when it does, there's a huge pileup. So if we want to start to look into why maybe this is happening the way it is, what's causing this, are there other aspects of the system state that can help me identify what's going on here and maybe how I can avoid this behavior moving forward, I then start to layer on these other charts and maybe look at things like the process list queries view. So this is going to show me a snapshot of exactly what's going on when I see those long running statements in the process list as they execute. And I see that select statement at the top here with this red peak essentially is growing in total time until it drops off right before the pile up here. So what I might want to do is look at the backend activity and look at the process list states and threads to see, is this maybe a system that is over or under resourced in terms of the connections that we're requesting at one concurrent moment in time. We do see some overcorrection here, but nothing out of the ordinary. So I can actually take a look at the process list states, and around this same time that we see this contention for those resources, there's a waiting for global read lock event. So from the perspective of multiple different metric charts and ways of looking at the system state at a given second in time, I'm able to start to answer some of these questions where I would have to pull this data from a disparate series of sources and really dig into these more complex performance problems without, having this visual analysis that makes it easy to line things up and essentially look over a specific time frame when these things changed. So this really helps with the reactive troubleshooting and the ability to, as you see something, maybe performance degradation start in production, you can very quickly start to build these troubleshooting dashboards and essentially stack all these different metric charts in one view and then save that as a template later so that you can answer that question with a matter of 2 clicks and looking at a few charts. So that kind of goes hand in hand with the troubleshooting performance and also establishing the baseline and knowing what normal database health looks like on a regular basis. And then being able to answer that with those recommendations or kind of the proactive feature set that's in place to help you make sense of that data. We do have a great set of resources for that in place under the health best practices. So we'll start here and we'll also touch on events and alerting because I think that's a key aspect too with the proactive side of things. But with the health best practices, we have a variety of different buckets of different recommendations here. So as you can see, we have for different database types, whether it be the actual configuration of the server itself, and you would have, a variety of different recommendations. And then when I unfurl the specific recommendation, we see the individual occurrences of each database host itself that either might need improvement. So in this case, we're looking at resources that have passed that. But if this was not the case, you would see that this was violating a best practice, and there would be some additional analysis that points you to what you could do to tune this to better handle the workload. So I think a great example would be Postgres. I know that we've added quite a few here. And so across the board, we try and make sure that the team is looking at things like utilization of memory, handling the workload from a connection, IO, and other, really kind of nuanced configuration parameter perspectives, because all of these different database types do have a different level of sensitivity when it comes to the workload you throw at it and what resources are the key focus. So across the board, we have these great recommendations, whether it be, memory consumption for Postgres or Mongo specific related, ensure swap space is configured properly, which is a much, bigger concern for Mongo administration. So there's a lot of nuance into these recommendations, but I'm going to kind of simplify at the top here. There's a couple different buckets. So we have the actual database configuration. We also have some basic index analysis where cases where statements might be run without an index, and we see that that's leading to inefficiencies. We can pinpoint that in the case of Mongo. And then Postgres and MySQL, we have some great query level recommendations. So there's essentially the better part of 20 individual SQL analysis rules across, multiple different recommendations, where you would be able to see every single query that was violating this best practice across the board here. And I would be able to then click into that query and examine sample data for exactly what I'm looking at. So I can see here, this is one of the few that I need to add a where group or limit clause. And I can then examine that data specific to that query by simply clicking into that query ID. And then I can also, maybe examine a sample, start looking at the explain plan, and get to the bottom of what I could do to potentially add a limiter and improve this query. So I can see at the query detail level a lot of information, but I can also see an aggregate when there might be patterns to how to improve the workload, or things I could do where, let's say, my queries are tuned, but maybe there's resource utilization or configuration concerns where there are slowdowns because of other, tuning that we might need to be focused on. What we try and do is cover that across the board and map all of these kind of expansive rules across the whole environment, and then give you this static analysis page to easily walk through the different levels of severity and see, okay, are there a lot of critical issues I need to get to the bottom of? Okay, once I've knocked those out, I can focus on just the warnings. And we have plenty of customers who are happy to get these all down to zero and know that their database is running kind of on all cylinders. So with that, we also can do some additional analysis in the background with the events. So we did look at that through the context of change markers, but this kind of also touches on the alerting aspect, because I can look at, diagnostic level events, or even more specific threshold based events like long running query events, where I can see over the timeline that I'm looking at how often those events occurred, what query we're looking at, additional data related to what we actually saw here and why it matters, the level of severity, the host it ran across. But I can then set alerts based on this information and kind of use this as a baseline for understanding if there's problematic events in the system, like long running query issues or server stalls or other events that might point to performance degradations that are a result of um, you know poorly tuned queries or other uh, poor health kind of indicators about the server itself and its ability to handle the workload that it's being asked to execute on. So if I, for instance, want to set an alert on, let's say, MySQL server stall, it's as simple as setting an alert. I then get a timeline of when that event occurred, and I can see that I can select multiple event types and really customize how I want to, what specific behavior I want to alert on here. And then I can link that with a variety of different integrations and set specifics on how often I want to see it, if it should snooze, if I want it to silence after the first time, for instance. So I can get really custom with how I see this data on the end user side of things when that alert actually fires. But I also have a lot of different capability in not just alerting based on events, but on the threshold of individual metrics. So essentially, everything, whether it be at the query or database level, individual hosts, or across the board, everything is essentially captured as a time series metric that I can use to create a threshold alert on based on that metric exceeding a value over a certain period of time. So to illustrate this, I think a great example is just a very basic Postgres throughput related metric. So as I start to type out, and if I were to maybe type M, it would give me all these other prefixes for different database types. But as I start to type out the metric name, the engine here will actually help me fill out based on the naming convention. So I don't even have to fully know exactly what I'm looking for outside of, CPU or memory. As long as I can get started, this will help me fill out the rest as I go. So I can quickly start to type out and add the rest of the metric name and get the value of that metric over the last hour, day, week, or month. And I might try the MySQL equivalent, see if that gives me some better data here. So I'll give that a hard refresh. There we go. And we'll just create a fresh alert. So I'm not sure what's happening with the metric time sampling here, but essentially you would be able to see the time series of that metric. What I'll do is show that from the example here. You would be able to see essentially this time series of the value and then set a threshold and recovery threshold that lines up exactly with the time series. So you'd be able to catch those potential spikes that you might otherwise miss by looking at samples of the data itself. So the whole point of the alerting is really to get specific with whether I want to alert on the threshold of an individual metric or an event that we're automatically tracking on the agent side. I have a lot of flexibility, and then I can also ship those through a variety of different integrations, whether that be Slack or Teams, Opsgenie, PagerDuty, VictorOps, or you can send your own JSON payload through our custom webhook option. So there are a lot of custom integrations that are available through that as well. So with this, you have kind of the full suite of your database and query level metrics, being able to see how things are changing. And then when you run into issues, you can very quickly notify the team using a variety of different integrations to kind of stay on top of performance issues before they raise even bigger problems, or to potentially respond to something very quickly that you might otherwise not have visibility into. And so with that, that's kind of the full end-to-end how we use DPM proactively, reactively, and to kind of get that full level of visibility and monitor database health and understand how things look on a consistent basis. So with
Awesome.
that, I think we have some questions, Jared.
Yeah. David, I didn't know if you wanted to moderate some of the questions coming in.
Absolutely, yeah. I'll moderate the questions, but if you see questions that catch your eye, feel free to bring those up. We do have a
Okay.
poll question that I want to run for the audience while we do our Q&A. So I'm going to pull up that poll right now. I want to call everyone's attention to that. The poll on the screen says, what additional information would you like about the SolarWinds Database Performance Monitoring solution that you just saw a great demo of? So I'll leave that up while we take your questions. Let's see. First question I see here that came in, they're asking with the SQL Server processless queries, would it be possible to write the problem query and its plan in a table in another database, maybe in JSON? That would be incredibly useful. Is that possible?
So that's a great question. I believe at this time, that's not something that you can natively do within DPM simply because it's a passive read-only metric capture where we're not writing anything additionally after the fact. So we're not writing anything to the database, but you could potentially do a manual export of data from that profiler view if you were to see something. There's just no native integration at this time because we generally avoid writing data. It's more a metric capture tool. So, but that is a great idea, and it's something that I actually am going to put in front of our product team in terms of something that we might be able to see in the future, because I think that would be very helpful.
Very cool. I love to get this kind of feedback from real IT pros out there and improve the product over time. So that's awesome. Next question here, they're asking, they say DPM is a great solution and very powerful. Is there an audit feature to track who and when changes were made? Are there any security and compliance reports that can be scheduled to run daily, monthly? Does DPM check for vulnerable configurations and suggest recommendations or best practices? So a three-part question there.
Yeah. So if you could hit me with the first part again, maybe take this one step at a time.
Yeah, absolutely. So the first one
okay,
is there.
I see the question. Yeah. So the audit feature to track who and when changes were made. So DPM is very, very strictly a monitoring solution. We don't have as much in terms of the management or administration level offerings. We do have the ability to track, database size and table and collection size. So you can see as tables grow and as dead space starts to grow, on those individual tables and collections. But in terms of auditing, we don't really have a whole lot in terms of workarounds there, because it's a different approach at looking at that login data. But there are some, like the host authorization metric is something that you can look at in terms of individual logins on the database server itself and authorizations, but it's not a full spectrum auditing solution. So I would say that I think there's some other SolarWinds solutions that have some of those auditing features more specifically built out for the auditing purposes. And the security and compliance reports, that would definitely be something that would be included with the auditing feature. So that's unfortunately something that's not available. And then vulnerable configuration and best practices. The best practices page I didn't highlight the specific examples, but there are quite a few Mongo related security configuration recommendations that we flag, as well as SQL injection related for the relational database types. So there are a few security configuration recommendations we can flag across the board, and we'll service those on the best practices page.
Excellent. And this is kind of along similar lines here. They're asking, how easy is it for a company to configure the monitor to protect highly sensitive data?
That is another great question. So we have multiple configuration control settings in place for the agent at the agent level. So essentially, you would have the agent as a local metric collector installed in your own infrastructure, and you would set the rules at that agent level on what data can and can't leave the network, whether that be you can't send explain plans or sample query text that might have PII and the raw bind variable place. We can control what data is sent and what isn't sent. And you can just basically rely on the performance statistic data that's fully anonymized if you can't send any of that out of the network.
Very nice. Let's see, Dale is asking, is this available for Amazon RDS or Postgres databases?
Yes, it is. So we do cover managed database offerings across AWS, Azure, and GCP, whether it be MySQL, Postgres, and Mongo Atlas as well.
Nice.
As well as the
And then
Azure
Ted,
SQL and SQL Server offering too. Sorry.
okay, great. And then Ted is asking, what distinguishes SolarWinds Database Performance Monitor compared to other SQL monitoring tools?
That's a great question. So we try to have a focus on being able to give you that really deep query level analysis, but also not lose you in too many really deep analysis tools. It's really focused on a balance of monitoring, analysis, being able to get full depth into the query level data, but also correlate query performance with system behavior. So you have that full picture, but it's not every dimension of the infrastructure or system level state information. We try and really focus on the key resources that point to where the degradation happens. So we give the full picture, but we also try and offer a solution that developers and DBAs alike can get up to speed quickly in and use to actually solve problems in a tangible way.
Excellent. And then what's the easiest way for folks to get started with this solution?
So you should be able to Google Database Performance Monitor, and we do have a free trial registration. I believe by default it's a 14-day evaluation where you can just give it a shot. You have a handful of trial licenses to spin up and some install guidance that's provided in the application. So you can give it a shot on your own infrastructure and see how it works, and then move forward with a purchase if it seems like the right solution for you.
Excellent. All right. Well, I know we're starting to run out of time here in our webinar time slot, but I want to encourage everyone again to respond to the poll question that you see there on the screen. We do appreciate your feedback. And also don't forget to check out the handouts tab there for 3 different resources about the solution that you just learned about. And with that, I'm going to go ahead and announce our Amazon $300 gift card winner. This is going out to Dale Malcolm from Pennsylvania. Congratulations. We'll reach out to deliver that prize, and also we'll be contacting the best question prize winner as well after the event. So with that, let's go ahead and wrap it up. I want to say a big thank you to Nick and Jared. Really excellent presentation and demo. Thanks so much for being on.
Thank you.
Yeah, thanks everyone for attending.
And thanks to our audience out there, of course, for attending, for all the excellent questions, for responding there to the poll. For more information, visit solarwinds.com, and we'll see you next time. Have a great day. Bye-bye.